Hello and welcome to Unit 4 of the Environmental Science course. This unit will be broken up into multiple parts. This is the first part, which is called Part 4A, and at the end of this part there will be a quiz just on this part of Unit 4. So each of the individual parts will have their own quiz. The cartoon that you're looking at here just shows an Australian farmer who is feeding his cows by hand and implying that he's very hardworking, earning all of his money. Whereas in the picture on the right, talking about in Europe, the subsidies that the government pays farmers, that's a picture of former French President Jacques Chirac. And that's more of a political cartoon, but we will mention briefly about how subsidies can actually sometimes lead to maybe bad decision making by farmers and then the impacts on the environment. First, more about our diet, the food that farmers do provide for us. There's over 350,000 plant species that are known, but of all of them, we really only eat just a handful of them, saying about 100 are grown commercially. And so of the 350,000 known plant species, you go into the supermarket, you're only going to find about 100 of them. Both protein and carbohydrates have the same calorie content per gram, about 4 calories per gram each. In this part of the discussion, we're referring to calories kind of as a good thing because the whole purpose for eating is to get the energy from the food. And if we consume no calories, we would starve to death. Protein should make up about 30% of your calories, whereas carbohydrates should be about 60%. And then fats have a higher calorie content per gram at 9 calories per gram, and they should really not make up more than 10% of your diet. Along these topics of proteins and fats are meat, and really eating meat is not a good thing for the environment, definitely not to the amount that how much meat Americans eat. Notably here, it's saying that it takes 16 pounds of grain to make 1 pound of meat. And it's a pretty inefficient way to get your calories. And you're thinking you need the meat for protein, and that's not really true. If you ate the grains that were being fed to the animals, you would get 20 times the amount of calories and also 8 times the amount of protein. So the issue here with the calories, I want to remind you of the second law of thermodynamics, saying that the entropy of the universe is always increasing, but also what that has is that when energy is transferred from one thing to another, some of the energy is always wasted. So in the animals eating the grain, it doesn't mean that they're getting 100% of the calories contained in that. And then when we eat the meat, there's another loss, and it's a pretty inefficient way to get the calories and the protein. So we could definitely live without eating meat, but even more realistically, just lowering the amount of meat consumption. There's a statistic here saying that 90% of the grain grown in the United States is to feed animals. That would not just include meat animals, but also dairy-producing cows. I think that estimate might be a little bit high. I've seen elsewhere 70% of the grain grown in the United States is to feed animals. But it's a difficult thing to quantify. But when you're driving out in the country somewhere and you see acre after acre of corn or other crops being grown, usually the majority of that is being raised to feed the animals. There's definitely a disproportionate amount of meat consumption in the rich nations. So the top 1/5 of nations in terms of money eat 4/5 of the world's meat. The good thing about meat is that it is a concentrated form of protein, which we do need, the amino acids, to build our own protein. Picture here showing you 2 breakfast meals just for example, and they have the same amount of calories. And if you look on the right, this is implying that the unhealthy way of getting your calories, and the 2 donuts look very delicious there. And so that the amount of calories, and there's 2 donuts and there's a cup of coffee there. I guess we're supposed to suppose there's maybe sugar in there, that you could get the same amount of calories from the meal on the left. which has toast and eggs and even a little bit of sausage there. Some jelly on the spoon, and there's even some fruits. Looks like pineapple, strawberry, and even bananas over here with a little bowl of cereal and even milk for the cereal. So, what would you rather eat? The issue here is saying that you could actually eat more food for the same amount of calories. The issue here is with energy density, that the meal on the right has a high density of calories, and that you're even by eating two donuts, you're only getting 144 grams, whereas on the left, you're getting to eat 450 grams, which will fill your belly more and probably be more satisfying. So why would somebody even eat the two donuts? Which of these breakfasts is easier to make? You could go to a box of donuts, open it up, and pull one out or two out and eat them. The meal on the left, for breakfast especially, it would take a long time to make that, and especially with breakfast, people don't want to invest that much time in making breakfast. In a healthy diet is one where they say you avoid the middle of the grocery store, that you go around the perimeter. That's where the produce is found and the fresh vegetables and fruit. If you go to the middle of the store where the aisles are, that's where all of the boxed foods are. And some health food advocates will tell you don't buy anything in a box in the supermarket because that's the more processed food. And they also, besides being more processed, they tend to have a higher energy density, meaning more calories. Talk for a moment about malnutrition. Um, it's just basic. The definition of it is really just people not getting enough nutrients or perhaps either protein or calories in their diet. And the first bullet point here is that poor nutrition causes almost half of the deaths worldwide of children under 5 years old, and that is 3.1 million children that die every year. And even that statistic, it's really hard to quantify this because sometimes children die of something related to malnutrition, but the cause of death might be listed as something different than malnutrition. And with poor nutrition, they might be less resistant to diseases and things like that. Weakens their immune system. One thing that might not be immediately obvious is that Asia is actually the continent with the most hungry people in the world. 2/3 of the total hungry people in the globe live in Asia. And there's some trends here about Southern Asia. That percentage has actually fallen in recent years, but in Western Asia it has actually increased a little bit, at least lately. The third point there, 1 out of 6 children, and that's in the whole globe, about 100 million children in developing nations are underweight, considered under the weight that would be considered healthy. The next point there is that there are 805 million people in the world do not have enough food to lead a healthy, active life, and it's about 1/9 of the total population of the globe, saying even to have enough energy to work, to just take part in a normal lifestyle. And the last point there is that sub-Saharan Africa is the region with the highest prevalence of hunger, meaning a bigger percentage of their population is hungry, and it's 1 in 4 people in Africa, the sub-Saharan part of Africa, is considered undernourished. And there's a little picture at the bottom there pointing out that hunger in the globe kills more people than AIDS, malaria, and tuberculosis combined. So back to agriculture, where we get our food sources, a few definitions here. Traditional agriculture is the type that uses human and animal power, much like the Amish do in the United States. Outside of the Amish, you're not going to find too much in the United States, but in some of the less developed parts of the world, there are people still using horses and other animals as well as their own hands to do the agriculture. Polyculture is where different crops are planted in one field, and poly just meaning many. Looking ahead, the last definition on this page is monoculture, which would be where you just grow one crop in a field. Back to the third point here, organic farming is one that just uses more of non-chemical and non-GMOs. So it uses techniques such as crop rotation, green manure, would be not just animal manure, but also the waste from when crops are picked. For example, if you pick an ear of corn, the rest of the corn plant, the stalk, and even the shuckings from the corn can be returned to the soil to return the nutrients. Compost is also included. That's where you waste it. The waste parts of plants are kind of put all together and with some soil and mixed up and then spread on the field. Biological pest control, meaning using beneficial insects and those sort of things. But there are strict limits on synthetic fertilizers and pesticides, GMOs, and really to not add any of those things to the food that's fed to animals. Industrial agriculture, which is becoming more common, that uses large-scale machines such as, not just large tractors, but even large combines and large farm equipment and other types of processing. And of course, these things use fossil fuels, which has an environmental impact. The tractors that running the big trucks that take the food from the farm to the warehouse to the stores. Irrigation is also a big part of industrial agriculture, as well as fertilizers and pesticides. And then monoculture, which is in the United States what the majority of farming is, that's where on a large field you would only have one single crop. So you're having just corn or just soybeans in one field. It is more efficient to grow food in this way, but it reduces biodiversity. And that's a recurring thing in this environmental science course, is that reducing biodiversity is always a very negative thing. If you have a field with one crop on it year after year, it's going to be more prone to disease and pests. The same bugs, if they know that they can get a free lunch in a field every year, they're going to keep coming back. So the incidence of pest issues will increase in a monoculture field. It also makes our diet more narrow. Like we said, even in a store, you're likely to find fewer than 100 different plant species on the shelves. And because some crops are easier to grow and more profitable, they farmers are growing fewer and fewer types of crops. And monoculture is the preferred method of industrial agriculture. So here's a couple of ways that beneficial farming techniques that can be used without using chemicals and perhaps even reducing the amount of chemicals needed. These are ways to protect the soil. So along with farming, erosion of soil is always a concern, as farming does lead to higher soil erosion. But a couple of ways to reduce that is crop rotation. That's where you're growing different crops one year to the next. And it also means if one crop has a tendency to take one nutrient from the soil, growing that same crop on the same soil every year is going to deplete it of that nutrient. If you change crops every year, it'll lessen that problem. It will reduce pest and reduce erosion. And examples would, you could grow wheat or corn one year and soybeans the next, something like that. In the bottom picture, this is an image showing intercropping, and that's where you are planting different crops in alternating bands, and this actually increases the ground cover. When you have exposed soil, that's when the erosion gets worse. So if you look at the picture on the right, you can't actually see too much soil, which is good. And then in the picture on the top, even the left-hand side of that, you can see a lot of exposed soil. So when you use intercropping, more of the soil is covered. And this will also decrease the incidence of pest and disease, and it replenishes nutrients to the soil. So protecting the soil, another way to do it is to reduce the tillage. Tillage, the definition is up here, the conventional method, which breaks up the soil and exposes it and then smooths it before planting. This is done with a plow, something that a farmer will use a tractor, and it just has these little spades on it that cut into the soil and turns it over. And when you do that, then you have the soil exposed to the air, which makes it more susceptible to erosion through the wind and water as rain and runoff. And the picture here is showing you no-till farming, where you can see that this has not been tilled. that the last year's crops or the last crop is still, although dead, it's there and it is protecting the soil from erosion. So this conservation tillage is reducing the amount of tilling, and there is something called no-till farming, where you're just planting seeds pretty much directly on top of the dead crops from the. It's still planting the seeds into the soil, but not turning over the soil since last year's harvest. The Green Revolution. This is something that has actually had a very profound effect on humanity, which is not an understatement either. But it's something that you've probably never heard of. If you look at the Green Revolution, this was a movement that started in the 40s and continued. The heyday of it was in the 60s, and you would think something like the Green Revolution means a return to basics or things like organic farming and things like that, and it's actually the exact opposite. The Green Revolution was mainly the work of this fellow in the picture, Norman Borlaug, and he even won the Nobel Peace Prize in 1970 for his work on what he did for this Green Revolution. And he really pushed for the use of technology, new crop varieties, not genetically modified organisms, which we'll talk about more in a moment, but more of doing crossbreeding and things like that to come up with better crops to plant. And he was a proponent of farming practices such as inorganic fertilizers, meaning chemical fertilizers, pesticides, irrigation, and these are some of the techniques that are considered the opposite of green by people who are in favor of organic foods and things like that. So this is actually the exact opposite. So he started in the 1940s. Mainly in the 1940s, he worked with wheat crops in Mexico and came up with some new techniques to grow wheat in Mexico, messing around with some of the different varieties he's seen in the picture holding wheat. And he looks like a younger man there. So this was a pretty long time ago, and actually developed a technique where farmers could grow two crops of wheat in the same field in the same year, which had never been done before, doubling the amount of production per acre that they could get. And it really had a huge benefit for the people of Mexico, where wheat has always made up a large part of their diet, and being able to produce more of it. And although Mexico is still economically depressed, it's not they're not suffering from famine there the way that other parts of the world are. Um, the Green Revolution is especially associated with the 1960s and what he did there. In 1961, India was on the brink of a major famine, something that would have had a very profound effect on a very largely populated nation. And his reputation for what he did in Mexico got him invited to India by the Secretary of Agriculture there. And he had major success in India by developing a new strain of rice that was called miracle rice. And through that and use of irrigation, they decided to start just in Punjab region of India, because they have a history of good agriculture and a lot of water for irrigation. And there was a major success, and they started growing more rice. And now India is actually one of the world's major exporters of rice, whereas they were on the brink of a famine in the 1960s. So over the decades that followed, not only are they producing enough for themselves, they're actually exporting. He did a similar thing for the Philippines, whereas they were not growing enough food for themselves, and now the Philippines are an exporter of rice, and so on. So the Green Revolution, it allowed food production to keep pace with population growth, but the techniques are really not sustainable. Plus, with the population growth is really what's not sustainable. So with all the people who are not starving to death, they're also consuming more. So there's definitely, the man has saved a lot of lives with his ideas, but now there's also more mouths to feed. The benefits is that with the Green Revolution, they're getting more yield of food for every acre, and this will require less farmland. And turning land into farmland is also something that's bad for the environment. So this is a benefit not just to mankind, but also to other animals that are going to benefit from increased biodiversity. Some of the negative things, uh, the Green Revolution, irrigation is a major part of that, and the use of fossil fuels because of machinery and technology, such as even a tractor compared to a horse-drawn plow. The Green Revolution techniques definitely rely on vehicles such as tractors. It's fertilizers and pesticides are a big part of it. Of course, these things have an effect on pollution. The erosion from there's an increased erosion from the industrialized farming techniques, and desertification is the turning of what was once healthy land, turning it into a desert. So, along with this, the Green Revolution techniques require far more energy than traditional methods for farming. Um, Low income farmers, meaning just a small family farm, especially in these poorer nations, they just can't do these techniques because of the money, the investment that it takes. So the little farmers who can't afford the technology are going to be pushed out of farming. The focus on high yield crops has also led to reduced agricultural biodiversity, meaning focus on the foods that produce well and stop growing foods that take too much of an investment of labor. And this has kind of narrowed the human diet. Uh, so Borlaug, part of the reason he won the Nobel Peace Prize, him and his Green Revolution, it's estimated, they call him the man that saved 1 billion lives. That when they look at the famines that were avoided in Asia, and he did a lot of work in Brazil and Mexico, that he's estimated to have saved 1 billion lives. In the 1980s, Africa was to be the next place to use this Green Revolution, but at this point, the efforts of environmentalists who are normally people who are looking out. They tend to be liberal-minded people, left-wing. They Most of the Green Revolution was funded by the Ford Foundation, the Henry Ford Foundation, Rockefeller's Foundation, and even the World Bank. But environmentalists went and got those organizations to stop giving money to this because of what they saw as negative effects on the environment. And the 1980s, also there were major famines in Africa that probably could have been avoided if they had allowed the Green Revolution techniques to be introduced in Africa. That may or may not be true. Africa has some problems that Asia didn't. Mainly, there's widespread corruption in Africa. There's a lot more nations. There's less infrastructure. So it wasn't the same situation as Asia. But here's a quote from Norman Borlaug where he says, at the time, that some of the environmental lobbyists of the Western nations are the salt of the earth, but many of them are elitists. They've never experienced the physical sensation of hunger. They do their lobbying from comfortable office suites in Washington or Brussels. If they lived just 1 month amid the misery of the developing world, as I have for 50 years, they'd be crying out for tractors and fertilizer and irrigation canals and be outraged that fashionable elitists back home were trying to deny them these things. Um, Africa is still not growing enough food to support itself. So some of what he said, and he only died back in the early part of 2000. I think it was 2004. He passed away at the age of 95. So the quote was made back in the 80s. Um, but the environmentalists do have some valid points. People in India have gone and looked in the region of Punjab where the Green Revolution started in the 1960s, and there is a higher incidence of cancer amongst the people living there than there was before. Also, the techniques of monoculture, reducing biodiversity, fertilizers, and irrigation that's needed. Irrigation is necessary for the Green Revolution techniques. And the environmentalists do have valid points. It's not a case of one party being right and the other one wrong. It's more of what problems do you want? Do you want the famine problems, or do you want the environmental problems? And again, that's what really science faces, is oftentimes you're not solving problems, you're just trading one in for another. The Green Revolution is a very interesting topic, and it's all we really are going to say about it here. But I would encourage you to look up some of this on Wikipedia when you have the time to read about it, especially all the specific things that he did in different nations, such as in Brazil and Mexico. But we do have to move on. Okay, genetic engineering and crop production. So even despite the Green Revolution increasing food production, there's relentless population growth, and as we go with an increasing population, we're going to need more innovation to feed the world's population. So science altered the genes of organisms, both plants that are grown and even livestock, animals that we eat. And this is where genetically modified organisms come from, that we shall be calling GMOs moving forward. So genetically modified organisms, GMOs, can enhance nutrition, so they can actually genetically modify a plant to grow vitamins or even iron that's added to rice. It makes agriculture more efficient. It can make plants that will resist mold, pest, and drought, so that now if you have GMOs, you won't have to you won't have to spray as much pesticide. Less water is needed for irrigation, and less fungicide and things like that. Um, there's a bullet point here that says the risks are not well understood, leading to anxiety and protest from consumer advocates, small farmers, environmentalists, critics of big business. And the anxiety that's felt by the population over this might not actually correspond to the risk. There's the companies that are promoting genetically modified organisms are some of the companies that have made pesticides and things like that. And there's a lot of distrust of big business, but especially people who favor eating organic food are really maniacal about their resistance to these genetically modified organisms, that people really dedicate their entire day to researching and really wanting these things to be bad, and then trying to find evidence that supports that. A lot of this is fear of science. It's fear of something that people don't understand. There's a lot of opinionated statements that are made on this topic which are not researched. It is true that these genetically modified organisms come from big business. They're not coming from little mom and pop operations. You need a lot of money to research them, and people think that automatically makes them a bad thing. What is not understood by a lot of people is that the companies that produce the GMOs spend a tremendous amount of money researching and a lot of time researching the effects to make sure that they are safe. They think that they're untested, which is untrue. Companies, and it's even voluntary, that the government doesn't force them to even spend as much as they do on the research of the effects, but they do spend the money to make sure that they're safe. We doesn't guarantee that they're safe, and then there's really no way to tell that they are safe unless people eat them for a long period of time, and then we can look at general population trends, if there's any illnesses that are popping up and things like that. But the people who are most vehemently opposed to the GMOs also tend to be those that are favoring organic foods, and even some of the people that are resistant to getting their children vaccinated. And these are really well-intentioned people who, a lot of the time, they're educated people, but they're also they want to believe that these things are harmful, and that carries a lot of weight and makes them resistant to change their mind to it. So the last thing here is that, at least in the United States, 75% of all crops are GMOs, and the big things there are corn, cotton, alfalfa, and soy. So these are these are things that I can assure you most of you have eaten today even. So genetic engineering, this is how it works in a laboratory. They take a bacteria, and this plasmid is actually the DNA of a bacteria that, unlike what we have as a strand of DNA, they have a ring. That's called a plasmid. And then they will take a cell from another organism extract a gene that they want to put into maybe another organism, and they actually can cut the plasmid using enzymes and chemicals like that, and insert the gene into the plasmid, and then the bacteria, as it grows and reproduces, will actually start to generate that piece of DNA, and bacteria, cell division and reproduction happening very rapidly, produces a lot of the DNA, and then that DNA is inserted into the targeted organism. In this picture, they're showing you corn, and certainly corn is accepting a lot of GMO, changed DNA. So that's the basic process of it. Throw in a couple definitions that we'll need to move forward. Biotechnology is the application of biological science to create products derived from organisms. And it has created medicines, cleaned up pollution, dissolved blood clots, and made better food. This work is all being done by big businesses, though. It takes a huge investment of money to do this. Genetic engineering are definitions just to put genes that code for desirable traits such as rapid growth, nutrition, requiring less water, things like that, and even less pesticide, putting them into organisms that lack those traits. And then the organism that accepts the DNA, that's called a transgenic organism, and that's an organism that contains DNA from another species. So we have to clarify something here, and that is selective breeding versus the genetic engineering. Selective breeding has been going on for many centuries, maybe millennia, where if you want to create a bigger animal, you take some babies from one litter and you take the biggest one, and you find the biggest baby from another litter, and you have them mate, and then they're going to have bigger babies. So there's any kind of domesticated animal. There's wild chihuahuas were never roaming the planet. They were all made by selective breeding. And these are changing of organisms through select of the same species, and just it can be done. In farming has been taking advantage of this for a long time. You can work with organisms in the field. It's really just genes. You're mating two members of the same species that possess a desirable trait, so that their babies will possess that desirable trait. This is compared to genetic engineering, which leads to GMOs. This is where you take genes from different species. This example says spiders and goats. If you took DNA from a spider and put it into a goat, what could you do with that? But just for example, they're two different species. They can't mate, but you can take DNA from one and put it into the other, and it has to be done in a laboratory. This can't happen. Selective breeding does not require a laboratory. Anyway, it directly creates a novel combination of genes. You're actually creating new DNA, new genes, and it resembles the process of mutation in that you're changing DNA. Biotechnology is changing our world. So GM foods, again, they're part of big business, and most GM crops, most GMOs that are grown are herbicide and pest resistant. To be clear here, they're actually herbicide resistant, so that if you have a field where you have a lot of weeds, you could spray chemicals that kill the weeds, but most of those chemicals would also kill your crops. So something like Roundup, which kills the grass that grows between the cracks at your house, but it would also kill your rose bush if you sprayed it on that. So through genetic modification, they can make crops that are resistant to the herbicide, so then you can spray the herbicide and it will kill the weeds, but not your crops. And then pest resistance, which is actually the largest part of genetically modified organisms. So large-scale farmers can grow crops more efficiently. And most of U.S. corn, soybeans, and cotton are already genetically modified. And a benefit of GMOs is that it has reduced the amount of pesticide. And a couple of images here. Soybeans make up for half of the genetically modified crops by type, and then followed by corn. Cotton, canola, most canola is used to make canola oil. And then by nation, the United States by far the largest user of genetically modified crops. Brazil and Argentina are large users. and then you see smaller countries, smaller genetically modified use in countries like India, Canada, China, and then 23 other nations. Notice you do not see any European nations. Europe is especially opposed to the use of GMOs. Okay, so an important part of GMOs is that the most GM crops are engineered to produce their own pesticide, and it's called they call it BT, and they actually can insert by altering the genes of these crops, have them produce their own pesticide, and that's it's actually producing the pesticide of BT, and like we said before, a lot are made to be resistant to herbicides. So then, what are the impacts of genetically modified crops? So here is really the example of BT. Insects could wind up building up a resistance to this BT, meaning it'll make the GMOs will not be effective anymore, and you'll be going back to using pesticides anyway. There's concerns about super weeds being created by cross pollination, meaning what if this gene winds up somehow into the DNA of these other plants like weeds, then they'll be less resistant to you know being consumed by insects, and they can wind up being taken off and really growing as wildly as the GMOs will. Pollen drift can affect non-GM crops. Uh, there's beneficial both 4 and 5 here. The BT is something that will kill insects, but it can actually hurt beneficial insects. Those would be insects that eat other insects. So that can have a negative effect, but also in the soil, there's organisms that live there, beneficial organisms that can be impacted by the BT. The effect on human health. The effects are not really fully studied. Some people believe they're not studied at all, but like we said before, there is a lot of money being spent on that. Hidden allergens in GM crops, although there's really nothing proven yet about that. Religious and moral opposition, where do the spliced genes come from and what we eat. The antibiotic use in GM plants could diminish their effect. And also biotech controls farmers, meaning that if you're a farmer, even a big farmer, you still don't get to choose the crops that you grow. You're really at the mercy of the company that's selling you the seeds. We're going to move into irrigation right now. Irrigation, the loose definition is just spraying water on your crops, but it's artificially providing water to support agriculture. And there are a large part of the world does not get enough enough water from rain to support crops. So there are parts of the world where otherwise unproductive regions can be turned into productive farmland. So here's a negative side effect is that if you water too much, if you over irrigate, that the water actually can suffocate the roots. So it can actually slow overwatering your plants can actually slow their growth. Here's a statistic which is very important, that 3/4 of the fresh water used on the planet is used for irrigation, not for people taking showers or flushing their toilets. It's 3/4 of all fresh water used is used to water plants. And here's an interesting statistic. 16% of cropland is irrigated, but it produces 40% of the crop. So it will make any land more productive. And another negative or bad statistic is that in irrigation, 70% of the water is wasted. In a sprinkler such as the one shown here, when it sprays out, a lot of the water evaporates instantly before it hits the ground, and the majority of the water that does hit the ground actually just gets into the soil between the rows of crops and does not wind up reaching the roots of the crops. So here's some improvements that could be made to irrigation. Again, sustainability, something that can be done forever. And one way to do that is to match the crops and the climate. You don't plant water guzzling crops in dry areas. So it's easier said than done because people might want to eat watermelon in a desert area like Las Vegas, but how do you do that? You're not going to grow plants like that in what's essentially a desert. And so one way to avoid or lessen the need for irrigation is just to match the crop with the climate. Beans or wheat do not require as much water as rice. Rice is something that needs almost total saturation to grow. So that's another way to lessen the amount of irrigation needed is to don't plant rice in a dry area. Here's what we're talking about with the first slide, the subsidies. Government can subsidize irrigation or maybe provide the infrastructure of water pipes to bring water to farms and things like that. And it actually makes the water cheaper than it really should be. And it promotes bad farming practices, really. So the last comment here is about drip irrigation delivers water directly to the plants, and that's what you see in the picture here, where you can see it's like a garden hose that runs and it's being supported on posts, and there's little holes punctured into the hose, and if you look very carefully, you can see the water trickling down directly on that plant. So you're not spraying it; it's just really kind of trickling out, so you don't get as much evaporation. You're not watering the soil between the crop rows, wasting all of that. So this is a much better, less wasteful method of irrigation. It does have limitations. It works on small plots with perennial plants like fruit trees. Perennials are things that come back every year, whereas something like corn, you grow it and when you're done, you cut it down. So something like this is really difficult to do on a large scale, and it is much more expensive than just putting out a giant sprinkler and turning it on. We're now going to talk about fertilizers. Fertilizers do boost yields. Definition of a fertilizer is a substance that contains essential nutrients to enhance crop production. Photosynthesis, the main ingredients are carbon dioxide and water, which the water comes from the rain, and carbon dioxide right from the air. But plants do need other nutrients, things like nitrogen and phosphorus. And if you keep growing crops on the same piece of land every year and then taking the food out of there, you're also removing the nutrients like nitrogen and phosphorus, and they they don't get replenished unless you go through the trouble of replenishing those nutrients. So an inorganic fertilizer, this is more of what we would call a chemical fertilizer, something that comes from a chemical provider, a chemical industry is providing these. They can be mined, meaning taken right from the earth, but most of them are synthetically manufactured, and they're mineral supplements. They contain the nitrogen, phosphorus, and other things. Organic fertilizers, this is more of things that are so-called naturally produced. It's the waste of organisms or the remains. We're not talking about animal remains, but um, the manure definitely comes from animals, but the crop residues are, uh, for example, the waste part of plants that we don't eat. So if you grow corn, the only thing we're really interested in is the kernels, the cob of the corn, the shuckings, then the stalk itself are something that can be returned to the soil to return a lot of the nutrients. So we're not being wasteful. Fresh vegetation, this is sometimes called green manure, which is not an animal waste. And then compost is when you kind of take all the waste vegetation and stuff, and you put it all together in a pile and let it start to break down. The organic matter is what's going to be broken down, and then when you get a bunch of it, you spread it out on the cropland. And all of these are examples of fertilizers. And again, this is to produce yields. Inorganic fertilizers, talk about that right now. They have boosted production, but they're also a severe polluter. And the leaching and runoff of inorganic fertilizers contaminates groundwater. A lot of it that winds up into rivers, which eventually lead to a larger body of water, has created dead zones in water systems and in aquatic systems. A big example of that would be the Gulf of Mexico. The Mississippi River drains 1/4 of the United States, and it eventually winds up into the Gulf of Mexico. And there's a lot of nitrates and phosphates wind up in the Gulf of Mexico. And we'll talk about that in more detail in a different unit. So just to give you that example for now. And actually the nitrates, as you know, nitrates are very water soluble. But if they're sprayed or something like that, they can actually wind up airborne, and that can lead to air pollution. So here's an interesting statistic, and look at this. If you only have to go back to 1960, and the use of inorganic fertilizer is nearly zero then. So this is something that only started in 1960, and you can see a pretty steep increase in the amount that's used. This point in the 1970s, there was an economic crisis, and so fertilizer use actually decreased a little bit when the economy went bad. But then things got better, and the use of fertilizers has actually increased dramatically. Looks like maybe in the mid 80s, that's when maybe people were starting to become a little bit more concerned about environmental things. So there was a decrease, but if you look, it's actually going back up again. And so we are still using more. So if fertilizers are good for crop production, the idea is to look for sustainable fertilizers. And some of these approaches are fertilizing it delivers nutrients directly to the plant roots and avoids over application, meaning if you can, instead of just spraying fertilizers, maybe inject them directly into the soil. So um, to do that, some of the techniques is to add the fertilizers. If you're using a drip irrigation system, add them to the irrigation water, and then you don't have to overspray where you're just spraying over a large area. This is going to focus your fertilizers where they're needed. If you use low till or no till systems, then when the seeds are planted, there's a device that's going to inject the seeds directly into the soil, and you can do inject the fertilizers along with them in much the same way. Um, this point here, monitor the soil nutrients and add only when they are low. Farmers have an option to them where they can actually take soil samples from their field and send them to a laboratory, and they'll be analyzed. And the lab might come back and say, well, your nitrates look good, but you're low in phosphorus, and you need this much. So they'll also be told how much fertilizer they need, and this will actually save the farmer money in the long run by not applying new fertilizers that they don't need. Like I said, if maybe they're told that their nitrates look good but the phosphates are low, they know that they don't have to spend money buying the nitrate fertilizers. So and also they can use less of it if they don't need it. So that's definitely something where technology and science will help the farmer save money and lessen pollution. And this here, putting strips of vegetation along the edges of fields. So if you can picture a large farm field, around the perimeter of it, put maybe a 20-foot wide patch of or ring of grass around the field, so that as the runoff from rain comes along, the grass will slow down the runoff, and that will allow the nutrients to not be carried off into natural water sources and remain close to the farm. And there's farms are big pieces of land, and sometimes you have streams and rivers running through them to also plant strips of these types of vegetation at the edge of the stream so that the runoff does not carry the fertilizer into the stream. Another thing, again, organic fertilizers, these add nutrients and organic matter. They also will improve soil structure. They tend to be more bulky, more than just a water soluble chemical. So something even like manure or plant matter will make the soil just more healthy in general. And the organic fertilizers, like the plant and animal waste, actually will retain water better. So the soil will not dry out as quickly, and you'll need less water for irrigation if you do use irrigation. Okay, so the last point here is if you maybe the most sustainable thing is to use a combination of both organic and inorganic, and that's probably the best way to go. So now we're going to switch gears a little bit and talk about pesticides, controlling the pests through pesticides and maybe alternatives. So synthetic organic compounds, and they're these are probably more dangerous than the fertilizer, even the inorganic fertilizers that are used, but they're also they also have a great effect in allowing farmers to produce more food per acre. So this said the first thing there, it has allowed 2 times the food production in developed countries and 120% in developing nations, meaning more than doubling. So it's the you know the pests that eat plants obviously would lower your yields, and it's got a bigger effect in developing nations. The next point, that's synthetic organic compounds. They would include insecticides, herbicides, fungicides, fumigants, and another definition here are POPs. This stands for a persistent organic pollutant, and there's 3 letters, 3 words here. Each one of them brings a different meaning. The persistent thing is because they don't break down in the environment, which is bad. Organic means more of an organic chemical, more of what a chemistry student would think of with the word organic. And then pollutant, you know what that means. But anyway, like we said, they're persistent because they last for a long time. They're chlorinated hydrocarbons such as DDT, and we're going to spend a few minutes talking about DDT in a minute. But the biggest group amongst the POPs are when you have a hydrocarbon with chlorine atoms attached to it, and we'll talk about that. Another problem is that they have a low solubility in water, which, in the one hand, is good because in the water systems they won't dissolve. But the unfortunate thing is if you eat them, if they're not water soluble, they will dissolve in the fat in your body, and things that dissolve in your fat tend to remain in your body. So pollutants and contaminants in your body that are water soluble, your body would get rid of them through the process of urination. But fat soluble pollutants or things actually remain in your body uh, really for forever. So that's the unfortunate thing about the POPs and anything that's fat soluble. Carbamates are 20 times more potent than chlorinated hydrocarbons, but they are more soluble in water, and that actually makes it easier for them to wind up in the groundwater. So that's the good and the bad with it. Um, the carbamates include the chemical that was produced at the Union Carbide factory in Bhopal, India. There is a major explosion there, and the chemical was released into the community around the chemical plant. 4,000 people were killed instantly, and over time, another 11,000 people died from illnesses directly related to that chemical exposure. And it's definitely known to people, at least that remember it. That was a very major news event when it happened, and some of the executives got from Union Carbide actually wound up getting jail sentences because of that accident. Um, the last thing here about this, you can, as an alternative to using these chemicals, you can use biological things such as ladybugs, the BT that we talked about before. Uh, BT is actually a living organism that that kills plant pests. So the BT can be used as an alternative. Okay, an issue with pesticides, they call it the pesticide treadmill here, is that the cycle of how a pesticide is used and then how it can become ineffective over time. So the cycle is this: you're a farmer and you have these pests and they attack your crops. So you apply a pesticide. You call up your supplier and they'll tell you what the best pesticide to use is. You apply it to your field and it's going to kill a lot of the pests. And so it says most of the pests are killed, but a few survive. Maybe they have a mutation that makes them resistant to the pesticide. Well, you killed off all the pests that were susceptible to it, but the ones that survived are resistant to it. So the few survivors, they mate, they produce babies that carry that gene, and they now the babies of these pests are also resistant to that pesticide. You apply the pesticide the next season, but the pesticide has less effect. And because this pesticide is now effective, you call up your supplier and they have a new product that's even more toxic than the last one. And so it is a general thing that as time goes on, the pesticides that are being produced are more and more toxic, not just to pests, but to humans. And the cycle just keeps going on and on. Okay, so there are benefits of pesticide use, otherwise we wouldn't use them. Like we said before, it has increased food production and it's made food cheaper. So even though the farmer has to pay for the pesticide, which would increase their cost, they're getting more product per acre to sell. So the overall effect is that it actually has made food cheaper. And the last thing here, a nice little side benefit, is that it reduces the number of pests in the environment in general, which means that few of them wind up on your kitchen counter. Okay, as promised, I want to talk about DDT. This was something that was one of the earliest and a very, very effective pesticide. And it's actually still a very effective pesticide that the resistance to it has not been built up yet. However, DDT wound up, after so many years, they realized the very negative effects that it had on the environment. So here's a couple of images showing you DDT is good for me, the commercials and the the promotion of DDT. Back in the day, if this is certainly before my time, but maybe your grandparents might remember that trucks used to just drive down the street spraying a fog of DDT to kill mosquitoes in neighborhoods. And they say how children used to run behind and play in the fog as they were spraying it, which is what you kind of see here. It looks like a fun thing a cloud to run through, but what it is DDT. A little bit of history on it. It was first synthesized in 1874. Wasn't really used as an insecticide until they realized in 1939 that it was very effective against insects. So the 40s and 50s, it was used for insect pests and crops. Malaria does not exist in the western, at least we're in the United States, and even into the areas south of the United States, malaria has been eradicated because of DDT. And the problems that came about is that, for one, it's toxic to humans. Another thing is that the DDT itself is toxic, but it breaks down and forms DDE, a slightly different chemical, which is even more toxic to humans. That's one thing, but one of the major problems with it is that it's persistent. It takes more than 200 years for the molecule to actually break down in the environment because it's such a stable molecule. And really, that's one of the good things that come out of this is the legislation that says that you cannot use persistent pesticides, things that take so long to break down anymore. So any chemical pesticide is something that the chemical company now has to prove will break down within a decade. It won't last in the environment the way that DDT does. DDT is soluble in fat, and that means that in your body, like we said, that the fatty tissue will store the pesticide, and once foreign things that are foreign to your body get stored in the fat, they stay there forever, and it will concentrate there over time, and it bioaccumulates as it goes up through the food chain. And the next slide will show an example of how the DDT bioaccumulated. It's called bioaccumulation or biomagnification, and here's how it worked. DDT is not very soluble in water. It's in a natural water body here. The DDT concentration in the water was 3 parts per trillion, very low concentration. However, to the zooplankton that lived in the water, it was exposed to it. So whatever DDT got into the zooplankton stayed in the zooplankton. So they're filtering water through their system, and the water comes in and water goes out, but the DDT is filtered out just like any food that the zooplankton would eat. Well, then you got small fish that feed on the zooplankton, such as minnows. So the DDT was concentrated in the plankton to a 0.04 parts per million. Then as the minnows eat the plankton, all of the DDT that's in all of the plankton that minnow eats in its lifetime remains in the minnow. It gets stored in the fatty tissue of the fish. So the minnow now has a 0.5 part per million concentration of DDT. And then a big fish eats the little fish. And so all of the DDT that's in all of the little minnows that one bigger fish has eaten now winds up in the big fish, and that big fish now has in its body a 2 parts per million concentration. Well, then the birds of prey that feed on fish, most notably ospreys, bald eagles, and falcons that eat fish, they get all of the DDT that was in all of those fish that it's eaten in the course of its lifetime. So in these birds of prey, they had concentrations of 25 parts per million DDT. So the problem with DDT, how it affects, why it's bad for the body, is that it's an endocrine blocker and it disrupts reproductive cycles in many animals, humans included. The birds of prey, the predatory birds, the DDT led to the shells of their eggs to be very thin, and when a bird would sit on its egg, it would break it, and then it stopped the birds from reproducing, and this nearly caused the extinction of the American bald eagle. Also, osprey and peregrine falcons, all three of these nearly went extinct in the world. The person who is credited for making this into an issue is Rachel Carson. She was a biologist. She worked for the Bureau of U.S. Fisheries, and she studied these, the effect of DDT. She noted in 1958 that DDT spraying near bird sanctuary caused many of the birds to die, and so she went to do research. And the only research on DDT she could find was performed by the chemical companies that made it. So she found there was no independent research on the environmental effect of pesticides. So she did her own research. 1962, she published a book called Silent Spring. This is an iconic book amongst environmentalists. It was really one of the first books to ever focus on, a pollution issue. And the title Silent Spring was referring to how in spring the birds would normally be chirping, but then spring became silent because the bird populations were decreasing due to the pesticide use. She pointed out in the book that for the first time in the history of the world, every human being is now subjected to dangerous chemicals from the moment of conception until death. And this is telling, from the moment of conception means when a baby is in the mother's womb, it's already being exposed to pesticides. Rachel Carson, this is a name that you will need to know, so try to make sure you study this before the exam. There's a few names that you have to know that you are responsible for, and Rachel Carson is a sort of a hero of the environmental movement. She actually was really targeted. A lot of smear campaigns were run against her, even personally attacking her, not just on her science, but on her who she was as a person. And so she never relented in her fight against it, and unfortunately she died of cancer before she saw a lot of her work, the benefits that came from it. She didn't live to see. DDT was banned in 1973 in the United States, and then in 1986 somebody did a study and just took random human samplings and found that the average human had 1.67 parts per million DDT in their fatty tissue, and this was 13 years after DDT was banned. So that's the persistent thing, and the fat soluble and being stored in fatty tissue, but it's also not breaking down. So DDT is still, it's not as, hopefully not as high in humans today, but every person on Earth could actually be studied and find DDT stored in their fatty tissue. The acceptable limit for DDT presently is 0.2 parts per million. That's kind of a weird thing to say, that there's an acceptable amount of it in human tissue. Okay, some other pesticides, moving away from DDT, organophosphates. These are organic compounds that have phosphate groups attached. These are extremely toxic, but they don't persist. They break down quickly, and that's why they're allowed, even though they are toxic. And a couple of the examples of them. Inorganic pesticides, these ones are what they call broad-based. Broad-based means it's going to kill a variety of insects, where other insecticides would be more focused, that they're there to kill one or two different species of insects, but The inorganic ones are broad-based, which means they'll kill any bug that they come in contact with. They use things like arsenic, copper, lead, and mercury. The thing about these, they can't break down. They're elements, so they will last forever. They are highly toxic, and they persist in the environment. So that's a double whammy. So the concept of integrated pest management, IPM for short, this is where you use you manage how using different techniques, and it actually lessens the amount of pesticide chemicals that are needed. And it's using a combination of things plus technology. So techniques to suppress pests will include biocontrol, that's using beneficial insects, for example, using living creatures to lessen the number of insects. Habitat alteration. Chemical pesticides are still used if they're necessary, but the good thing is that it greatly reduces the amount that you need. Crop rotation, so you're not going to get the same crop in the field every year, you won't get the same insects, where the population of the insects would get bigger and bigger every year. Population monitoring, meaning actually quantifying the amount of pests in a field. Transgenic crops, GMOs, which are dreaded by many people, but GMOs, a huge benefit is that they actually lessen the amount of pesticides that are needed. Using alternate tillage methods, mechanical pest removal, which is meaning could literally mean just going out and picking the pests off with your hands or whatever, something like that. So IPM is actually a very big topic in the United States. Any good farmer uses this, and not only does it decrease the pollution, it saves the farmer money. IPM in Indonesia increased rice yields by 13%, and it saved 179 million per year in phased out subsidies, meaning the government did not have to give as much money to farmers for them to survive. So between 1972 and 1996, the EPA banned 55 carcinogenic. Carcinogenic, that word means something that causes cancer. So the EPA has banned 55 pesticides that are carcinogenic that also bioaccumulate or biomagnify. The 1996 Food Quality Protection Act, the EPA set new standards for pesticide tolerance level in foods. So foods are tested to see how much pesticides they contain, and yes, your foods do contain pesticides, but it actually sets maximum values there. The companies that make the pesticides must do the studies that demonstrate that the active ingredient will not harm infants, children, humans, even grown-ups in general. Okay, and this is our last slide here. Another piece of legislation is the federal insecticide, fungicide, and rodenticide. Side means kill, so if you put side on the end of a word, it means it kills that thing. So there's a federal law, and it requires all the commercial pesticides to be approved by the EPA, and the EPA sets the tolerance levels for general or restricted use. So now that what that act did is it gave the government control over commercial pesticides, meaning if you're a chemical company, first you have to prove that it was safe by a prior legislation, but then even before you sell it, you need to have approval by the EPA. So that's the end of this this lesson. So you are now ready to take quiz 4A, and I wish you good luck on that. Goodbye.